Somewhere across Russia's rail network, more than 1,000 steam locomotives sit sealed inside hidden depots, preserved and maintained with crews still trained to operate them. It is a Cold War secret that never expired. In an era of hypersonic missiles and electronic warfare, a nuclear superpower is quietly investing in 19th century technology. The question is not whether this shadow reserve exists, it is what Russia believes is coming that makes it worth keeping. In the winter of 1941, as German armies closed in on Moscow, Soviet commanders issued a single urgent order: keep the trains running at any cost. Steam locomotive columns, entire battalions of engines, each with its own crew, coal wagons and water tenders became the arteries of survival. These were not scattered engines pressed into service, but organized mobile reserves, ready to be dispatched wherever the front demanded. Historian David M. Glantz, drawing from Soviet operational records, describes how the Stavka, the Red Army's high command, treated rail mobility as a weapon in itself. By the end of the war, more than 2,000 steam locomotives had been allocated to these columns, forming a mobile, fuel-flexible network that could adapt to shattered tracks, sabotage supply lines, and the constant threat of aerial bombardment. Each locomotive column moved as a complete unit. Engines, spare parts, maintenance crews, even rolling stock for repairs and refueling. When German panzers cut the main lines to Leningrad and Stalingrad, these columns rerouted entire armies through hastily rebuilt sidings, burning whatever fuel they could find: coal, wood, even peat bricks scavenged from the countryside. Soviet planners learned that in a crisis, the ability to improvise mattered more than efficiency. A steam engine could be coaxed to life with little more than a match and a shovel, while diesel and electric traction depended on vulnerable supply chains and intact infrastructure. This wartime experience left a deep mark on Soviet military doctrine. Archival footage from the period shows endless lines of black locomotives, smoke pouring from their stacks, pulling munitions and wounded alike through the snow. The memory of those columns, of rail as the backbone of national survival, became institutionalized. Orders from the People's Commissariat of Railways in 1945 directed that a reserve fleet of steam locomotives be preserved, not just for peacetime logistics, but as a hedge against the next crisis, whatever form it might take. The lesson was clear. When everything else failed, steam kept moving. This was not nostalgia, but a hard-won calculation. The Soviet Union emerged from the war convinced that mechanical simplicity and fuel flexibility were not relics, but strategic assets. The locomotive column became a model for future contingency planning, a template for a shadow logistics system that could survive sabotage, fuel shortages, or even the unthinkable, a technological shock that rendered modern engines useless. In the decades that followed, this memory would shape a uniquely Russian approach to military resilience, one that valued redundancy and worst-case preparation above all. In the early months of 1954, a new directive circulated through the highest corridors of Soviet power. The Council of Ministers, acting on lessons seared into memory by the war, issued a decree whose language left little room for ambiguity. The Ministry of Railways was ordered to preserve a strategic stock of steam locomotives for wartime use. This was not a vague guideline, but a formal, binding instruction, one that would become the legal backbone of a shadow logistics system designed to function when all else failed. The decree, cataloged in the State Archive of the Russian Federation, specified that these locomotives must remain fully serviceable, with stocks of coal, water, spare parts, and trained crews to match. It required quarterly inspections and annual test runs, transforming the reserve from a fading wartime improvisation into a standing pillar of Soviet defense planning. Implementation began within 3 years. By 1957, sealed depots, some underground and others camouflaged in remote forests, were established across the country. Locomotives were stored on dedicated sidings, their boilers drained and interiors coated with protective oil. Each depot was equipped with its own water towers, coal bunkers, and maintenance sheds. The infrastructure mirrored the scale of the reserve itself. At its inception, over 1,000 steam locomotives, drawn from the robust FD, SO, and P36 classes, were allocated to these sites. Politburo records from June 1956 show that the highest levels of Soviet leadership debated whether to scrap or mothball the fleet. The consensus, recorded in the session minutes, was clear. The risk of fuel disruption or technological sabotage was too great to gamble on a single mode of traction. The reserve would be maintained not as a museum collection, but as an operational insurance policy, one that could be activated if the modern system was ever brought to its knees. Archival documents from the Ministry of Railways trace the construction of this network in remarkable detail. Each depot was assigned precise quotas for coal and water, and inventories were updated annually. The language of these orders is technical, almost clinical, but the intent is unmistakable. The Soviet Union was building a parallel rail system in the shadows, ready to function in the event of catastrophe. By the late 1950s, the Strategic Steam Reserve was no longer just an institutional memory. It was state policy, codified in law and embedded in the physical landscape. The sealed depots, hidden from public view, stood as silent sentinels, testament to a doctrine that saw redundancy not as waste, but as survival. In the logic of Cold War planning, this was the ultimate insurance premium, a fleet that could outlast sabotage, blackout, or even nuclear shock. Steam locomotives, by their very design, stand apart from the modern machines that dominate today's railways. Their power comes not from precision electronics or imported fuels, but from a process as old as the industrial age: heat, water, and pressure. In the Russian Reserve, this simplicity is not a drawback. It is the heart of the system's operational advantage. At a sealed depot in Smolensk Oblast, a mechanic might check the firebox of a P36 class engine, knowing that with the right coal and a steady hand, the locomotive could be brought to life in a matter of hours. But coal is only one option. These engines can run on lignite, wood, peat bricks, even scrap timber. During shortages, crews have been known to scavenge whatever would burn, shoveling it into the firebox to keep the pistons moving. This flexibility is not theoretical. It has been tested in the field, from the forests of Karelia to the steppe near Khabarovsk. The Soviet Union's vast domestic coal reserves ensured that even if oil imports were cut or refineries destroyed, the trains could keep running. The mechanical robustness of these locomotives is just as important. The drivetrain of a steam engine is a study in basic engineering. Pistons, rods, wheels, and gears, all visible and repairable with hand tools. There are no microchips to fail, no circuit boards to fry. If a valve jams or a rod cracks, a skilled crew can improvise a fix on the spot, sometimes with nothing more than a wrench, a hammer, and a length of wire. Depot manuals from the 1970s describe field repairs carried out in blizzards and blackouts, with crews cannibalizing parts from disabled engines to keep a single train moving. The system's robustness is literal and practical. Unlike diesel-electric locomotives, which require refined fuel and a functioning distribution network, steam locomotives are almost entirely independent from the national grid. They need water, coal, and human skill, nothing more. In a crisis when pipelines are sabotaged or the power grid goes dark, these engines can be fired up with a match and a shovel. The supporting infrastructure remains just as practical: coal bunkers, water towers, and maintenance sheds, all maintained in parallel to the mainline network. Depot records show annual deliveries of thousands of tons of coal, stockpiled against the possibility of sudden mobilization. This is not nostalgia, it is a calculated hedge. The reserve's ability to operate outside the boundaries of modern supply chains makes it uniquely valuable in scenarios where everything else fails. Russian planners have always understood that the real enemy in total war is not just the opposing army, but the collapse of the systems that make modern life possible. By keeping a fleet of steam locomotives ready, Russia maintains a logistics backbone that cannot be unplugged or digitally disabled. The system's strength is its refusal to depend on the fragile web of electronics and refined fuels that define the modern age. In the logic of worst-case planning, the old ways are not obsolete, they are the last line of defense. In the shadowed corridors of Cold War strategy, Soviet engineers faced a dilemma few outside military circles could imagine. What if the next war erased electricity itself? Not sabotage, not fuel shortages, but a weapon that could wipe out the modern world in a single silent flash. Their answer came from the past. The Committee for High-Altitude Nuclear Effects, in 1974, ran a series of electromagnetic pulse tests, documented in the classified RGAV number 57 1974 report. The results were blunt. Diesel-electric locomotives, the pride of post-war engineering, failed catastrophically at field strengths above 5 kilovolts per meter. Their electronic control modules, alternators, relays, fuel injection computers collapsed under the invisible surge. The report estimated that after a 10-kiloton EMP burst at altitude, more than 90% of diesel electrics would be dead on the rails, their mass and power rendered useless by a force they could neither see nor resist. Steam locomotives, by contrast, barely noticed. Lacking microchips, solid-state relays, or digital brains, they survived the same pulse with little more than a flicker. Over 95% could be restarted, as long as there was coal and water. The physics was unforgiving but simple. Electrons jump, circuits fry, but steel, fire, and water endure. The Soviet findings were echoed 3 decades later when the U.S. Congressional EMP Commission, referencing Sandia National Laboratories, confirmed that even induced voltages as low as 1 kilovolt per meter could cripple modern diesel locomotives. Again, steam's mechanical heart proved immune. This was not just theory. Soviet planners, reading the numbers, ordered at least 100 steam locomotives preserved as a strategic reserve. In a world where electronic warfare could paralyze a nation's arteries, only machines untouched by silicon could guarantee the movement of troops and supplies. Manuals from the era spelled out post-EMP procedures. Check the boiler for cracks, light the firebox by hand, patch headlamp wiring if needed. Annual audits tracked each engine's readiness, with a single question at the top: could it run if everything else failed? The numbers drew a stark line. Over 95% of steam engines would survive a nuclear EMP. Fewer than 10% of diesel electrics could be trusted in the same scenario. The Soviet Union, and later Russia, paid the price for this insurance, year after year, keeping a fleet that could not be erased by a silent flash. Western railways made a different bet, trusting in electronic hardening and diversified fuels. The Russians, shaped by war and the threat of sudden catastrophe, chose redundancy, a hidden fleet waiting in the wings. In the contest between progress and survival, it is the oldest machines that may endure when the lights go out. Depot rosters and official logs strip away the myth. At its Cold War peak, the Strategic Reserve held over 800 steam locomotives, each tagged for preservation. Over time, that number shrank. By the late 1970s, just above 200 remained in active reserve, and the rest were sent to museums or scrapped. By 1990, only 45 were still listed as maintainable. Today, open-source audits and leaked Russian Railways documents confirm the reality. Just 12 engines survive at the Roslavl Reserve Base. None are operational. All await dismantlement. Maintenance records reveal how readiness faded. Annual inspections, once required for every A-grade and B-grade locomotive, stopped after the Ministry of Railways dissolved in 2004. The last scheduled boiler test at Roslavl, set for 2015, never happened. Quarterly visual checks replace the old pressure tests. Only 2 workshops in Russia still have the tools and expertise for full overhauls. Most depots now depend on outside specialists, working with fewer parts and less funding. Training followed the same decline. The Moscow Institute's steam module, once mandatory, ended in 2020. Live fire drills stopped in 2014. Retired depot masters remember the last successful run, a 150-kilometer test from Roslavel in 2009. Since then, the engines have stood silent, their status preserved only in paperwork, not in steam. Shrinking budgets and unpredictable fuel supplies have forced Russian logistics officers to reconsider every contingency. Internal contract documents from 2018 show a quiet but steady flow of coal deliveries to the Roslavel Reserve, even as official line items for steam maintenance vanished from the national budget. Each winter, a regional supplier delivers 500 tons of coal under a shadow logistics agreement, enough to keep a handful of engines ready for emergency drills, even if the rest of the fleet sits cold. Stress tests in recent years have exposed the cracks in the modern system. In September 2021, a scheduled emergency drill at the Roslavel base was aborted mid-run, not because of a mechanical fault, but because the depot could not field a certified steam crew. The paperwork records the failure plainly, but behind it lies a deeper problem. Years of deferred training and dwindling expertise, the result of cost-cutting and shifting priorities. Improvisation has become the rule. During 2022 fuel shortages in the Western Theater, reports from the Ministry of Defense describe diesel locomotives hastily retrofitted with coal burner generators. These jury-rigged solutions echo the original logic of the reserve. When diesel runs out and electronics fail, the only fallback is fire, water, and steel. Depot officers note in their logs that coal contracts and emergency drills persist, even as the reserve itself fades from doctrine. The old insurance premium is still being paid, if only in fragments, an echo of a time when worst-case planning meant keeping the past alive just in case the future breaks. While Soviet planners invested in a hidden fleet of steam locomotives, their Western counterparts took a different path. In the United States, the last regular steam freight run vanished from the rails in 1958. British Railways retired its final steam engines in 1968, closing the books on more than a century of coal-fired power. West Germany completed its own transition by 1975, integrating with European standards and betting on diesel and electric traction for the future. These decisions were not made in secret. They were public, deliberate, and rooted in a belief that modern fuels, electronic controls, and robust supply chains could withstand any crisis. Official policy documents from the era framed steam as an expensive relic, costly to maintain, labor-intensive, and no longer needed in an age of cheap oil and expanding electrification. No formal reserve was kept in the West. The United States focused on petroleum stockpiles, and later on hardening electronic systems. The United Kingdom, despite persistent rumors, never maintained a hidden fleet, and official inquiries dismissed the idea as myth. In West Germany, the push for modernization left no room for fallback technology. Only in East Germany did a small tactical reserve survive into the 1980s, and even that was a fraction of the Soviet effort. The divergence was stark. Where the West saw redundancy as waste, Soviet doctrine treated it as a necessity, a hedge against the improbable but catastrophic. The hidden reserve, with its coal piles and sealed depots, was not a product of nostalgia, but of a strategic imagination shaped by geography, resource insecurity, and the specter of technological sabotage. While Western railways embraced efficiency and modernization, the Soviet Union built a shadow system, prepared for a world where the unthinkable might become real. Somewhere beneath Russia's modern railways, a shadow logistics system endures. Obsolete to outsiders, essential by design. As EMP threats and energy insecurity grow, this hidden reserve signals a doctrine where resilience outranks innovation. The West scrapped its steam fleets, and Russia kept its insurance premium. In a world obsessed with progress, perhaps true power lies in what you never quite let go. What would you keep ready, just in case?